Hello guys, and welcome back to a new physics lesson. Today we will have the last session in our physics curriculum. The first topic we are going to study is the conductivity in solids. Let me ask you guys, how do solids conduct electricity? And what is the main reason of conductivity? And what is the difference between solids? What is the difference between solids as a conductor and different types of solids as insulators or even semiconductors? Before anything, just scan the QR code and watch the video. Then let's answer these questions. How do solids conduct electricity? What is the main difference between conductors, semiconductors, and insulators? The main reason of conductivity, guys, is something called free electrons. If the material has free electrons, so this material can conduct electricity, as these electrons can move from one atom to another atom. Any atom in the normal state, its electrons exist in something called valence band, as each electrons or each atoms own its electrons. After that, to make a conductivity, the electrons must be moved to something called conduction band. And from here the story began. If the electrons are able to move from valence band to conduction band easily, it will be a conductor material or conducting material. If the electrons are unable to move from the valence band to the conduction band, this material will be insulators. If it will move from the valence band to the conduction band in a condition of increasing its energy by adding heat, this material will be called a semiconductor. So its conductivity depends on adding heat or temperature to increase the movement of electrons and its energy. So, as we said before, here is the conductor. There is no gap between valence band and conduction band. Here is the insulators. There is a large gap between valence band and conduction band. This gap is called forbidden gap. This gap is greater than 2 electron volt in the range of 4-5 electron volt. But the gap in semiconductors is about 1 electron volt, 2 electron volt. So the electron can easily gain energy by heating the material up, so it will be able to overcome and jump through the forbidden gap as it has a small amount of energy and go to the conduction band. In this case, the electrons are able to move from one atom to another atom as long as these electrons exist on the conduction band. And as we said, that there is no forbidden gap between valence band and electron band, so the electrons move easily between valence band and conduction band, so this material will be a good conductor. Let's have some definitions, guys. How can we define the valence band? Valence band is the energy band occupied by the outermost electrons in the atom, while conduction band is the energy band where electrons can move freely to conduct electricity. So the electrons which exist in the conduction band are responsible for conducting electricity. Electron occupancy, usually fully or partially filled, with electrons because it has the valence electron of the atom. Usually empty in insulators and semiconductors at low temperatures, but in conductors it contains and includes electrons. Energy levels. Valence band has a lower energy compared to the conduction band, while the conduction band has higher energy compared to valence band. Electron movement. Electrons are bound to atom and cannot move freely. These electrons belong to the main atom and are unable to move freely. When the electrons transfer to the conduction band, so it can move from one atom to another atom. So in conduction band, electrons are free to move, contributing to electrical conductivity. Role in conductivity. Valence electron doesn't directly contribute to electric conductivity because they are belong to the same atom and they are unable to move freely from one atom to another atom. Otherwise, the insulators may have conductivity if these electrons are able to move while they are in the valence band. So the insulator is supposed to have or to show electric conductivity. But the electrons, when the electrons are in they are unable to move from one atom to another atom, so there is no conductivity. Conduction band, directly involved in electrical conductivity when electrons are present. So, what is the forbidden gap, guys? Forbidden gap is the energy difference between the valence band and the conduction band. Electrons in the valence band need to gain sufficient energy to jump across this gap to reach the conduction band. Then this material will be a conductor. The size of the gap determines the electrical properties of a material. We have three different materials: insulators, semiconductors, and conductors. In insulators, large band gap, like diamond, has an energy of 5 electron volts, which makes it difficult for electron to jump, so no conductivity occur under normal condition. Semiconductor, the material can conduct electricity in certain condition by adding some energy to the electron to overcome the forbidden gap. So the size or the edge of forbidden gap must be small and has low energy. So it's a moderate band gap. For example, it has 1.1 electron volt in silicon, allowing some conductivity when energy is supplied. Okay, how can we define a semiconductor material? Is a material that can act as a conductor in certain conditions and as insulators in others. Conductors, no or negligible band gap. There is no band gap. Electrons don't require energy to move from the valence band to conduction band. No or negligible band gap allowing overlapping of band or free movement of electrons, resulting in high conductivity. Intrinsic semiconductors, guys, are pure semiconductors that conduct electricity as a result of thermally freed electrons. We described before the positive charge and negative charge. We said negative charge is the electron itself, while the positive charge is the place of removed electron. So when an electron is removed from a certain place, it leaves something called hole or gap from this position, and this position will become positive. Here, a semiconductor that is surrounded by 4 electrons. Each atom is surrounded by 4 electrons. 1, 2, 3, 4. And another one is surrounded by 4 electrons. 1, 2, 3, 4. And so on. Another one is surrounded by another 4 electrons. So, when an electron moves from one atom to another atom, it's going to leave something called a hole in its place, which makes this atom unable to stay like this or remain with a shortage in electrons. So it's going to borrow an electron from the neighboring atom to overcome this loss. So now this one is the atom which owns the hole, and the electrons are moved from this atom to this one. In return, this atom will not stay without having a complete figure of electrons to be stable, so it's going to borrow an electron from a neighboring atom, let's say this one, and transferring the whole to this atom. So the whole is moved from this atom in this direction to this atom, and the electrons are transferred in this direction from this atom to this atom. The transferring of electron itself is the process of transferring electric current. By this way, the semiconductor is able to transfer electric current, electricity, be conductor, but there is a certain condition to move the first electron is adding thermal energy. This thermal energy will make the electron gain amount of energy to overcome the forbidden gap and jump from the valence band to the conduction band. So I need to make it more easily without adding thermal energy. So I need to make the electron free. I need a free electron or a free hole to make the movement of electrons without adding any thermal energy. Let's say that I have here different atoms. All of these atoms are tetravalent, which means it's surrounded by 4 electrons, as the previous figure. But I'm going to put some impurities. These impurities even to be pentavalent or trivalent. Let's talk about pentavalent first. Here is the atom of pentavalent. I'm going to put 4 electrons surrounding it, which makes a bond with the surrounded atom. And here is a free electron. This free electron will move from one atom to another atom. As long as there is a number of free electrons are able to move from one atom to another atom, this material will be able to conduct electricity. Here we are going to say that this type of semiconductor is a doped semiconductor. Doped, that means I added impurities. Okay guys, if I replaced one or added some impurities of trivalent and pentavalent, that means there will be a shortage in electrons. Let's say that here is the atom with 3 valent electron, not 4, which means the neighboring atom has an electron missed in the bond. So there is a hole here. This hole requires an electron from a neighboring atom. So it's going to borrow it. So the electron is going to move from here to here to close the hole and make these atoms stable, which is mean the hole going to move from this place or from this atom to this atom. After that, by the same way, this atom will not stand like this. It needs to overcome the shortage of electron. So it's going to borrow an electron from the neighboring atom and so on. The transferring of electron and holes conduct electricity. So I gave a reason for these atoms to move electrons and holes without adding thermal energy. So doped semiconductors is a semiconductor material that has been initially infused with small amounts of impurities to modify the electrical properties. The doping process enhances the conductivity of the semiconductor by introducing additional charge carriers. We have two types of carriers, electrons or holes. Electrons, so the material will be negative as it has more electrons, or holes, the material will be positive. Here's the figure which I explained. This one I added arsenic. Arsenic is a donor. It's a pentavalent. Pentavalent, that means it's surrounded by 5 electrons. So there is one extra electron. This extra electron will move from one atom to another atom. And each atom needs to lose and get rid of this electron. So it's going to pass it to the next atom. Here, gallium. Gallium is a trivalent element. So it has only 3 electrons surrounding it. So it's unable to complete or make 4 bonds, which makes a hole in a missed location of an electron. So it's going to borrow the electron from the neighboring atom. By this way, the conduction of electricity will happen by moving electrons or holes from one atom to another atom. Let's talk about or differentiate between N-type semiconductor and P-type semiconductor. Doping element is a pentavalent in N-type, while P-type is trivalent. Valence electron, 5 valence electrons, 3 valence electron in P-type. Majority charge, of course, is electron. Here, holes, absence of electrons. Minority charge is holes, electrons. Conductivity mechanism. Conductivity is due to the free electrons. Conductivity is due to the movement of holes from one atom to another atom. Position of Fermi level closer to the conduction band in the energy band diagram, closer to the valence band in the energy band diagram. What is the Fermi level? Here is the Fermi level. The Fermi level is the level which contains the charge itself. Here the charge is negative, so the Fermi level is located beside the conduction band. Here the Fermi level contains the positive charge, so the positive charge is beside valence band. So the Fermi level is the level which contains the charge. If the charge are negative, so it will be close to the conduction band. It happen and occur in N-type donor levels. And if the semiconductor is positive and the charges are holes, so the Fermi level will be beside the valence band, and this type will be B-type and acceptors level. Charge of doped region, negatively charged because it has extra electrons, positively charged because of the creation of holes and the shortage of electrons. Example, silicon doped with phosphorus or arsenic, or silicon doped with boron or aluminum. So we have 2 types of conductors, semiconductors. One of them is called P-type, and the other one is called N-type. And now we know the difference between them. Can we use these types of semiconductor in making some modern and more advanced electronics parts? Yes, we will do two electronics parts using these semiconductors. One of them is called triode and the other one is called transistor or triode. Diode consists of a sandwich of P-type and N-type semiconductors. We use diodes to support one direction of the electric current, which means the electric current can only move in one direction. As the diodes allow the electric current to move from N to P, not from P to N. As we said before, the electric current is the existence or the flow of electric charge, which are electrons. Electrons can move from negative to positive, but can't move from positive to negative. And we can use diodes in the process of transferring alternating current into direct current. As we said before, the alternating current has dual phase, which means it can be positive, negative, then switch to be negative, positive, then positive, negative, which makes this current alternating. While the direct current has only one polarity, positive on one side and negative on one side. By using diodes, we can change the alternating current into direct current by allowing the forward current only to pass. So what is the meaning of forward current and reverse current? Let's say that here is the diode. Diode, that's mean PN junction, PN junction. The holes are the P side contains hole, while the N side contains electrons. There is an area between them called depletion region. What is the depletion region? Is the area which doesn't allow electrons to move through. By increasing the thickness of this depletion region, the electrons will not be allowed to move from one side to another side. So there is no flow of electrons. By decreasing this area, that means the electron will be allowed to pass from one side to another side. If I'm connecting the electrons from this side, the electric current is moving here and the electrons are entering the PN junction from the side of N. So I'm going to add more electrons. More electrons will make the depletion region decrease because the electrons now are able to move and overcome the number of holes to produce a number of electrons which is already able to pass through the conductor. Exactly in this case, we have a certain or a sufficient number of electrons by adding them to N side. So N side is able now to pass this electron because it has already a great number of electrons, so it doesn't need to keep them for itself, and pass it to P. As long as the electrons are passed to P, it can close all the holes and make it pass through B to other side of the semiconductor and flow through the circuit. We call this conduction forward. So forward by connecting the negative pole of the battery by N side of the diode and connecting the positive by positive side of the diode. The reverse is when connecting. Here is N, and here is P, and here is the depletion layer. So now I'm going to connect and supply the electron from P side. At this case, B has a lot of holes and B is hungry for electron. B is hungry for electron. So it will keep all electrons to close and overcome the number of holes. By making more neutral side, that means the depletion thickness will increase. By increasing the depletion thickness, the electron will be unable to pass through it. The potential difference will increase. The electrons will stop passing through the junction. So I'm going to prevent the passing of electrons through the junction itself. So depletion region is the region around the p-n junction of a diode where there are no charge carriers and electricity is poorly conducted. Here is the shape of semiconductor. Here is the shape of p-n junction and how to be inserted in the circuit. Here are the holes and here are the electrons. As I told you guys, here is the forward connection. The electrons are able to move from the N to P, and from holes move from P to N easily, as we have a great number of electrons sufficient to close all of the holes, so the electron will and the electric current will flow easily. Here we provided the electrons from the side of positive holes. So these positive holes, as we said, are hungry. So it's going to keep electron to itself to be neutral, which increasing the depletion layer. The depletion layer is the region which exists between the P and N. By increasing its thickness, as we said, it prevents the electric current from the flowing through the semiconductor material. Let's compare between forward connection and reverse connection, guys. Forward connection, positive terminal of a battery connected to the anode and negative connected to the cathode. It allows electric current to flow through the diode. Low resistance in the forward base connection. A small voltage drop. As we said, we don't have a higher thickness of depletion region, so doesn't need a high voltage or doesn't consume a voltage for electrons to be passed from one side to another side. Battery barrier potential overcome in forward base, allowing current to flow. Application used in something called rectifiers and voltage regulates. As we said, rectifiers, that mean conducting or transferring alternating electric current into direct electric current. Voltage regulates, that mean make the voltage itself constant at a certain value without increasing or decreasing. Leakage current, negligible, there is no loss in the electric current. Breakdown phenomenon, no breakdown occurs under a normal condition. Electrons are able to flow easily. If you are going to talk about the reverse connection, in the reverse connection we said positive terminal of the battery connected to the cathode and negative to anode. Current flow, it blocks current flow except for a very weak leakage current. Something cannot be calculated. Resistance at high resistance. Voltage across the diode, high voltage is required to cause breakdown. Barrier potential is strengthened in reverse base, preventing current flow. Application used in reverse protection and voltage regulation by the same. Leakage current, a very small leakage current flows until breakdown occur. Breakdown phenomenon, breakdown occur if reverse voltage exceed the breakdown voltage. If the voltage is more than, if the voltage is very high and more than the breakdown voltage, let's say we are going to use a diode of 12 volts, so it's going to hold 12 volt or 15 volt. But if we connected this diode into 220 volt, which is mean it's unable to hold this voltage, and the potential difference is very high now, so it's going to overlap and overcome the depletion region and pass through the diode, so the diode or the connection itself is unuseful. The second type is transistors or triode. In triode we have two types, PNP or NPN. The transistor is used in amplifying the electric current. So it's a device made of doped semiconductor materials that can be used to amplify the electric current, and all of this is the only required description for this part of transistor. Which of the following material has full valence band and empty conduction band at absolute zero? Insulators. In a semiconductor, the energy gap between the valence band and the conduction band is typically 1 electron volt. What is primary charge carrier in N-type semiconductors? Electrons. Well done. Doping pure silicon with phosphorus. Phosphorus is pentavalent atom, creates pentavalent, so it has one more electron, so it will be N-type semiconductor. The region in PN junction diode devoid of free charge carriers is called the depletion layer. Moving to a new part, guys, and the description of nucleus. This part is common between physics and chemistry. We are going to study this part from the perspective of physics. Atoms consist of dense, positively charged nucleus that is surrounded by electron cloud. The nucleus contains positively protons and uncharged neutrons. Protons and neutrons are collectively referred as nucleons. So, any particles inside the nucleus are called nucleons. The number of protons is the atomic number, which is equal to Z, or represented by Z. And the number of nucleons is the mass number, and represented by A. The mass of proton or neutron is about 1 atomic mass unit, U. And atomic mass unit is equal to 1.66 times 10 to the power negative 27 kilogram. Here is the symbol, element symbol. Atomic number is Z, mass number is A. The mass number is always greater than atomic number. What are isotopes? Isotopes are the same element with different number of neutrons, which mean the atomic number is the same while the atomic mass differ. Here, hydrogen isotope, it has only 1 proton, 0 neutrons, so the atomic number is 1, while mass number is 1. The first isotope, deuterium, has 1 proton and 1 neutron, so the atomic number is 1 and the mass number is 2. Tritium has atomic number of 1 and mass number of 3. As you can see, guys, and notice the number which is changed is the mass number, and as a result of changing the number of neutrons. What is the strong nuclear force? As we said, guys, any particles have the same charge, they repel each other, which means that protons must repel each other while existing inside the nucleus. The force which holding them together must be greater than the repulsion force. This force is called a strong nuclear force. The protons in the nucleus repel each other, but the nucleus doesn't fly apart because an even stronger attractive force exists within the nucleus. Strong nuclear force is an attractive force between nucleons that are close together as they are in a nucleus. A strong force has a range of on the order of 10 times negative 15 meter. So this force appears in very, which is mean tiny distance, 10 of power negative 15 meter. Outside this range, the effect of the strong force are minimal. The strong nuclear force has the same strength between nucleons pairs but doesn't affect electrons because electrons outside the nucleus. The strong force is also responsible for holding together the particles that make up protons and neutrons, and we're going to study it by the end of this session, inshallah. So, neutron and the neutron has a strong force. They are neutral, so there is no repulsion force. Proton and protons, they are positively charged, they are going to repel each other, but the nuclear strong force keeps them holding together. Proton and the neutron, there is no repulsion force because one of them is positive and the other one is neutral, and the strong force holding them together. What is the meaning of mass defect, guys? If we are going to find the mass of a certain atom, so it's easily, we have to find the mass of the component of this nucleus and the component of the electron cloud. As long as the mass, as you studied in chemistry, is neglected, the mass of electron is neglected, so the mass of particle inside the atom is the nucleus. Nucleus contains protons and neutrons. So the total mass of protons and neutrons, suppose, to provide the mass of the atom. But they found there's a certain difference or a little difference between the calculated mass and the real mass. This difference in mass is consumed or changed into energy to hold the nucleons together. So mass defect is the difference between the sum of the mass of individual nucleons and the actual mass. Binding energy is the energy difference between separated nucleons and a simplet nucleus. The binding energy can be expressed in the form of equivalent amount of mass according to Einstein's famous equation E equal mc squared. At this scale, the most convenient unit of mass is atomic mass unit. So we are using atomic mass units. You are going to find the mass, the total mass in atomic mass unit. And the energy is used in the term of electron volt. And as we said before, if I need to change electron volt into joule, I have to multiply it by the charge of one electron, which is 1.6 times 10 to the power negative 19. If I'm going to change a mass into energy, so 1 unit provides 931.49 million electron volt, which is mean any decrease in the mass, any mass defect, multiplied by this amount of energy for each unit will provide the value of binding energy. Let's solve an example to understand. Use the information in the table below to compare the mass defect and binding energy of deuterium H12 with that of helium-2-4. 12, that's mean the atomic number is Z, the mass number is 2, which is mean it has one proton. Hydrogen here has one proton and one, here has one proton and one neutron. Helium-2-4, which is mean it has 2 protons and 2 neutrons. We are going to calculate the mass, the actual mass, and the mass defect to find the binding energy. He gave you the mass of hydrogen atom, the mass of neutron, the mass of the deuterium atom, and the mass of helium. The mass of hydrogen atom provides the mass of proton, because we said hydrogen is 1,1. It has no neutrons, so it has only one proton. So the mass of hydrogen atom represents the mass of proton. So he would like to know the mass defect of deuterium, the binding energy of deuterium, the mass defect of helium, and the binding energy of helium to compare between them. First of all, let's find the mass of deuterium. I'm going to add the mass of proton plus the mass of neutron together. So now I have the mass of parts of deuterium. Let's calculate the defect. I'm going to subtract the calculated mass from the real mass, actual mass. So I'm going to find the mass defect is negative 0.002388 unit. Calculate the mass of helium parts. So helium has 2 protons and 2 neutrons. So here is the mass of 2 protons and here is the mass of 2 neutrons. Adding them will provide the mass of helium, actual mass of helium. Subtracting the actual mass of helium from the calculated mass, we find the mass defect of helium and also it with negative charge. Then comparing them, the binding energy is equal to mass defect multiplied by 931.49. So I'm going to multiply the deuterium mass defect by unit, atomic mass unit, multiplied by the convert ratio into energy. So the binding energy is negative 2.2244 mega electron volt, and helium is negative 0.003, the mass defect multiplied by the value of conversion to find that by the end negative 28.296. And we said before, negative sign represents the decrease in mass by converting it into binding energy. Nuclear decay and reaction. To describe the nuclear decay, we must know that some atoms, especially isotopes, became unstable with large amount of nucleons inside it. So it must get rid of some neutrons or protons to be stable. And this process occurs by something called radioactivity. The phenomenon is called radioactivity and the process is called decay. We have different types of decay according to the situation of the atom itself. It can lose 2 protons to neutrons, alpha decay. It can change neutron into proton. It can change or lose certain energy, change the energy content, but by losing some energy without losing particles. So we need firstly to define some physical terms. Radioactivity is a property accepted by certain types of matter to emit energy, and subatomic particles. So it may emit only energy, it may emit energy and subatomic particles spontaneously. Spontaneous, that means without any interference, due to the decay of unstable atomic nucleus. It's unstable. We are talking about the nucleus itself. The nucleus here is unstable. This process leads to the transformation of element and the release of ionizing radiation. Radioactive material, substance that contain unstable nuclei. So, radioactivity, we defined the process itself. We defined what happened. While the radioactive material is the material which is doing this action. So the substance that contain unstable atomic nuclei and undergo radioactive decay, emitting ionizing radiation. In the process, these materials can be naturally occurring or artificially produced. A decay is the process of losing. It's not the phenomena, it's the process. So radioactivity is the phenomenon. Radioactive material is the material. Decay is the process which includes the losing of particles or even energy. The process by which unstable atomic nucleus loses energy by emitting radiation, resulting in the transformation into a different nucleus or different energy state. This process continues until a stable state is reached. So, radioactivity is a phenomenon. Radioactive material is the material which doing or losing or making the decay itself. Decay is the process. Radiation is the product of decay, of radioactivity. Energy given by matter in the form of rays or high-speed particles. This includes alpha particles, beta particles, gamma rays, and other forms of electromagnetic waves. Nuclear reaction. It's a process the structure of atomic nucleus is altered through interaction with another nucleus or particle. So during a certain reaction, this nucleus became radioactive and able to make a decay. So this reaction, we call it a nuclear reaction, leading to the release or absorption of energy and transmutation of elements. This includes both spontaneous process by itself, like radioactive decay, and induced process such as nuclear fission and fusion, which happen inside nuclear reactors. Here are the three types of decay, the most famous three types of decay: alpha decay, beta decay, and gamma decay. In alpha decay, the atom loses alpha particle. Alpha particle consists of 2 protons and 2 neutrons. So the nucleus will change into another nucleus of another atom. As it is very massive, so it has the least penetration. It can't penetrate different materials because just it's big enough. It has 2 protons and neutrons. So the penetration will be very weak. The atomic number going to lose 2 as 2 protons are produced. So the atomic number Z will decrease by 2. The mass number will decrease by 4, going to lose 2 protons, 2 neutrons, and the number of protons will lose 2. Beta decay. In beta decay, 1 neutron change into 1 proton. So the number of protons will increase, and atomic mass will be the same as only 1 neutron change into 1 proton. Changing 1 neutron into 1 proton doesn't affect the atomic mass or the mass number, as if we have 5 neutrons and 5 protons, so the total is 10. If 1 neutron changes into 1 proton, so it will be 5 plus 6. By the end, it will be 10. So beta decay doesn't affect the mass number, but it increases the atomic number by 1. Increasing the atomic number by 1 will change the atom from one element to another element. It produces beta particle, which is negative particle, has a charge of -1. It has a medium penetration. The atomic mass is the same. Atomic number going to increase by 1. The number of neutrons will decrease by 1. Gamma decay. Gamma decay doesn't include any particles. It's only energy. So it has high penetration. There is no change in particles number, only the change in energy. As we can see, guys, alpha decay. Here the atom lost 2 protons and 2 neutrons, which represents the helium nucleus. And the atomic number changed, the atomic mass changed, so the material itself or the element itself changed from one element to another type of element. Here also the element change as the atomic number increases by 1, while the atomic mass remains the same. Mass number remains the same. Nuclear reaction occurs whenever the energy or number of neutrons or protons in a nuclear change. Here is a substance called uranium. It made something called alpha decay, so it changed from one element to another form or another type of element. As the number of protons changes, so the element itself changed. The atomic number was 92 and became 90. If we added these numbers, 2 plus 90 will present 92, and 4 plus 234 will present 238. So this substance, it makes the decay by itself without interaction, spontaneously, without interaction from the human, So it has something called half-life time. What is the half-life time? It's the time required for half of the atoms in any given quantity of a radioactive isotope to decay. We can calculate the half-life time by this rule, guys. If you have the original substance and the remaining substance, so we are able to calculate the time. If we don't have the remaining substance but we have the half-life time, we can calculate the remaining substance after the half-life time. Nuclear activity is the decay rate or number of decays per second of radioactive substance, activity proportional to the number of radioactive atoms present. Therefore, the activity of a particular sample is also reduced by 1/2 in 1/2 lifetime. This activity of a sample is also related to its half-life. The shorter half-life, the higher reactive. So the rate change of atoms is very fast. The SI unit of decay per second is becquerel, and becquerel is the scientist name who discovered the radioactivity. A remaining is the quantity of the substance that remains after a certain time t. Original is the initially quantity of the substance at time equals 0 before it starts the decay. T is the number of half-lives that have elapsed. A half-life is the time required for half of the original amount of a radioactive substance to decay, as we said before. We have two types of nuclear reaction. One is called nuclear fission and other one nuclear fusion. What is the difference between them? The nuclear fission is the division of a nucleus into two or more fragments. So here we have one atom of a certain element. This atom divided into two different elements. One of them is krypton and the other one is barium with different atomic numbers. One of them has 36 atomic number and the other one 56 atomic number. Nuclear fusion is the merging of two nucleus to have a larger nucleus, which may be unstable after that. So the nuclear fusion, nuclei with small masses combine together to form a nucleus with large mass. In the process of nuclear fusion, energy is released. This corresponds to a loss of mass. An example of fusion is the process that occurs in Sun, where 4 protons fuse in several steps to form a helium nucleus. So here is 2 protons, and here is another 2 protons. These 2 protons fuse together to produce 1 proton and 1 neutron. Then another proton will help with them producing gamma radiation. And this process occurs here by the same steps. By the end, we have 2 protons and 1 neutron. 2 protons and 1 neutron. They're fused together, releasing 2 protons out and remains with 2 protons and 2 neutrons. All of these steps produce, as you can see, guys, energy. So the nuclear fusion is the source of energy in our life for Sun. Which of the following particles are found inside the nucleus of an atom? Protons and neutrons. An element has an atomic number of 15 and a mass number of 31. How many neutrons does it have? 16. Well done. Isotopes of an element have the same number of protons but different number of neutrons. The strong nuclear force is responsible for holding protons and neutrons together in the nucleus. Well done, guys. Calculate the mass defect of helium 4 nucleus, 2 protons, 2 neutrons. He gave you the mass of proton, mass of neutron, and mass of helium. So I'm talking about helium, 2 protons, 2 neutrons. So I'm going to multiply this one by 2, multiply this one by 2. Then add them together, subtracting them from the nucleus to find by the end the defect. Do it by self, guys. It's so easy. Then the final answer will be 0.02928 unit, atomic mass unit. Binding energy per nucleon is a measure of, so it will be the stability of a nucleus. Accelerator, guys, is a set which is used to accelerate a certain particle, to shoot the nucleus with this particle and make it unstable, moving the nucleus from a stability figure, state, into unstable figure or state by shooting the nucleus itself with a certain particle. Shooting the nucleus with this particle requires an accelerator to accelerate and make the particle, which we use as like a bullet, to be very fast, to reach high speed, which makes this particle able to penetrate the nucleus. An accelerator may be made smaller by using a magnetic field to bend the path of the particle into a circle. So we use something called magnetic field to bend the path of the particle into a circle. The bending magnets are separated by accelerating region, which operate in a similar way of this linear accelerator. As you can see, guys, we have electromagnets. These electromagnets able to make the particle move faster in a shape of a circle to reach a higher velocity, a higher speed, and be able to penetrate the nucleus, as you said. So the most important point in the particle accelerator is the path, it's a circular path, and is the field which is used, and it's the magnetic field. Particle detector. To detect a particle must interact with a matter in some way. If you would like to know the type and to detect a certain particle, you have to make interaction between this particle and a certain matter, like exposing film, ionizing matter, fluorescence, make a light, something like light. All of these are detectors. If you exposed a film to X-ray, so it's going to draw certain passes and certain shapes on this film. So you detected X-ray. Beginning in the 1930s, scientists have been discovered a wide variety of particles. They have also found something called antiparticles. And antiparticles is a material which we use it to detect the particles, which are also called particles of antimatter. Each antiparticle is associated with a particle. The particle and its antiparticle have the same mass and charge magnitude, but the signs of their charge is positive, like positron and electron. Positron is the same mass of electron but has a positive charge. And we found that, the scientists found that the nucleons itself is formed by a smaller particles, like quarks and leptons, or even something called force carrier or force producer called gauge bosons. You have to know, guys, the difference between these particles. Quarks are fundamentals, constituents of matter that combine to form hadrons, like protons and neutrons. It has different types. We call it flavors: up, down, sharp, strange, top, and bottom. They have a certain electric charge: up sharp top, positive 2/3, and down negative 1/3. Spin is the direction of rotation. It has a certain direction, even to be clockwise or even anti-clockwise, so we call it half, which is called fermions. Fermions, that means it has a certain direction of rotation. Leptons are fundamental particles that don't experience a strong interaction, includes electrons and neutrons, because electrons are very small in mass and the neutrons have no charge. They also have 6 types, 6 flavors: electron, muon, tau, and their corresponding neutrinos, the opposite of each one of them. Integer charge is a charge of of them, -1 for electron, muon, and tau, or 0 for neutrinos. It also have fermions, as we studied in chemistry. When electrons are occupying any orbitals, they're going to, according to Pauli principle, they have different spinning number, positive half and negative half. Gauge bosons, they are forces. So they are force carriers that mediate the fundamental interaction force between particles. Their types are photons, W and Z bosons, gluons, and hypothetical gravitation. The charge varies. Photons and gluons have 0 charge, while positive boson has +1, negative boson has -1, 0, Z boson has 0. Spin one boson part is this part, guys. He is going to ask you about this part. What are the quarks that form proton, neutrons, and electrons? So nucleons are made up of 3 quarks. Any nucleon made up of 3 quarks. Individual free quarks cannot be observed. You can't see individual, because the strong force that holds them together becomes larger as the quarks are pulled further apart. So you can't see any individual quark. The proton is consist of 2 up quark and down quark. Neutron, 1 up quark, 2 down quark. So the charge is 0. Electron, not composed of quarks, doesn't compose of quarks, so it has a negative charge, and we called it lepton. Elementary protons and neutrons are pierion composite. Moving to the 4 fundamental forces, guys. Gravitational force, electromagnetic force, strong and weak nuclear force. Weak, we call it interaction. Weak force, nuclear force, we call it the weak interaction. Strong force, we call it strong nuclear force. Gravitational force affect particles with mass, force carriers, gravitons, range, infinite range, relative strength, 10 to the power -36, relative relation according to other forces, always attractive, there is no repulsion, holds together large scale structures that such as planets and galaxies. So holds together large scale structure. It holds the structures with huge masses together. As the mass increases, the gravitational force also increase. So it holds the planets and galaxies, stars together. Electromagnetic force affects electrically charged particle, force carrier photons, infinite range, relative strength 1. So we measure any force according to the electromagnetic force. Can be attractive or repulsion. Holds atom and molecules together. Atoms and molecules moving inside the atom itself. So we are talking about weak interaction, affect quarks and leptons. Force carrier like W positive, W negative, and Z bosons. Different bosons, type of bosons. Its range of 10 to the power -18 meter, very weak and limited. Its strength, relative strength, is 10 to -7, which means that it's stronger than gravitational force. Responsible for beta decay. Strong force affect quarks and hadrons. Force carrier gluon. It has a bigger range than weak interaction, 10 to the power -15 meter. It has a strength, very strong. It's the most strong force exists, which is relativity 20 according to the electromagnetic force. Binds quarks into hadrons and hold the nucleus together. It's responsible for holding the nucleons inside the nucleus together. So, gravitational force is responsible for holding large masses together, like galaxies, planets, and sun, stars. Electromagnetic forces hold molecules together and atoms. Weak interaction force responsible for beta decay, and it makes a weak, what we call it, a weak nuclear force. A strong force, it holds the nucleons inside the nucleus together. Which of the following particles is a fundamental constituent of proton and neutron? Quark. In a particle accelerator, a charged particle are accelerated primarily by electric field, then using a magnetic field later inside the accelerator. A proton is composed of which combination of quark? 2 up quarks and 1 down quark. Which of the following particle is lepton? Electron. The process by which neutrons decay into a proton, emitting an electron and anti-neutrino, is known as beta minus decay, because the particle produced is negative particle. So guys, we reach the end of our session and the end of our course. Study well and be ready for live sessions. Collect your questions, and inshallah, good luck.